use your calculator to check your determinants to make sure they are correct. If you end up with a determinant of 0, what does that mean? That means that there's no inverse, which means then you can't get a solution, okay? You can't determine technically whether it would be an infinitely many solutions or a no solution answer. All you just know is that you're not going to end up with an actual physical solution by not having an inverse.
So he said no solution, is it wrong?
Well, you would say can't be determined or can't solve or does not exist. All right, so we found our determinants. So now what's going to happen is we're going to get to Kramer's rule. So I'm going to have you take a second to jot this down. And then after you have it written down, 'cause it's a whole lot of craziness, we're going to discuss it. And you are going to be responsible for remembering Kramer's rule. All right, so what Kramer's rule says is if you are given the following system, and all we're using is just subscripts of 1 and 2 to deviate between the first equation and the second equation. So if you have a sub 1x plus b sub 1y equals c sub 1, and a sub 2x plus b sub 2y equals c sub 2, and when you go to calculate your determinant, it's not equal to 0. So as long as your determinant's not equal to 0, if it was equal to 0, then it would be unsolvable. So as long as my determinant of my coefficient matrix, which you guys should know how to do, top left and bottom left, make your diagonal products, subtract them, then you can use Kramer's rule. And what Kramer's rule does is it creates different matrices that you're going to find the determinants of and then divide those numbers. So to get your x value, you're going to find the determinant of C1, C2, B1, B2, which notation-wise gives us the determinant of x in respect to x, divided by A1, A2, B1, B2, which is just your regular coefficient matrix, right? Those are my coefficients in front of my variables. So whatever that number is divided by that number is your x. Then to find your y, you're going to take and find the determinant of A1, A2, C1, C2, and you divide it again by the determinant of your coefficient matrix. So when I make these notations, I'm going to be using a D with a subscript of y to stand for finding the determinant with respect to y. And I'm going to use my x, the D of x, to determine the determinant of, to get the determinant of my matrix with respect to x. So this is how you remember it. It looks confusing, but it's not too bad. We all know how to come up with the coefficient matrix, right? That's just what's in front of your x, what's in front of your y. We ignore the stuff on the other side of the equal sign. So that's your regular determinant. It's always in your denominator. Now to get your matrix in respect of x, notice what's happening is they're taking the solutions matrix, which remember we got our solutions matrix over here. We are multiplying it by our inverse. So we're taking that solution matrix and we're inputting it in place of my coefficients of my x. You see how that worked there? So I took my solutions and inputted those numbers in my column that represents your x coefficients. Does everybody see that? So the same thing happened for your y. So what happened? I took the solutions and inputted it in place of the column for your y's. Does everybody see that? So to get your matrix in respect to x, you take your solutions, input in place of x. Right here. To get it in respect of y, take your solutions and input it in place of y. It's very confusing with all those a, b's, and c's. But I want you to see it. But it's easier in practice. Okay, so let's go ahead and solve a system. Here we go. So we've got the system 2x minus 3y equals negative 26. 3x plus 4y equals 12. So 2 by 2s are going to be our best friends because it's easy just to do a quick diagonal multiplication and subtracting and then divide out at the end. So the way I'm going to organize my thoughts is I'm going to find my determinant of the coefficient matrix first, which is just 2, 3, -3, 4. What's my first product going to be?
8.
Yep, because we're going to do 2 times 4, which is 8. And then I'm going to subtract from that -3 times 3, which is -9. So 8 minus a -9 gets us 17. Good. Now I'm going to find my determinant with respect to x. So that means I'm going to take my -26 and 12 and replace it in the first column. So instead of 2 and 3, I'm going to put -26, 12. And then the y's stay the same, -3, 4.
Wait, I don't understand. Wouldn't it be like -26 times 2 and 12 times 3?
No, it goes in place of it.
Just
It's not going in place of x, it's going in place of the
full
coefficients.
value, okay.
So -26 times 4 is -104 minus a -36. I feel like thinking, so -104 plus 36 is -68.
So when you put those in for the x,
We don't put it in for x, you put it in to replace the elements in the first column. It's just the way that I remember it is when I'm solving for x, I put it in the column that represents the x. So you're not putting it in place of x. So d of y, what would that matrix look like? Who thinks they got it?
2 minus
What would be the first column? It would be 2 and
plus 26.
3, -26 and
Wait, wouldn't it be? Oh wait, yeah.
12.
So even the sign, the whole thing was replaced, even if it's a negative.
Right, because when you do matrices, you forget the variables. You just focus on the numbers. That's the purpose of matrices.
That's like the sign between the variables.
Well, it's a -3 is your coefficient.
Okay.
All right, so top left first, 2 times 12 is 24, minus 26 times 3 is 78, -78. So 24 plus 78 gets us 102. All right, so now let's find our x, now let's find our y. So we said that x is equal to the determinant with respect to x divided by the determinant of the coefficient matrix. So -68 divided by 17. Is that -4? Yes. And my y is my determinant with respect to y divided by the coefficient determinant, which would be 102 divided by 17. I don't know what that is. 6. So my ordered pair would be -4, 6. Make it fancy. Kramer's rule. Okay. All right, let's do another 2 by 2 before we throw the 3 by 3s at you. All right, so now I'm going to give you this system. 5x plus 7y equals -1. 6x plus 6y is equal to +1. So to find my coefficient, 5, 6, 7, 6. So like now that we know that if the determinant was 0, that we would not be solvable. Like if I just was given this right away, I would just do a quick mental spot check. 5 times 6 is 30. Is 6 times 7 30?
No,
No, so that means it's probably going to have an answer, right? It's just a nice little tidbit to have in the back of your brain, thinking about determinants. All right, so here we go. 5 times 6 is 30, minus 6 times 7, which is 42. So my determinant is negative 12. Now let's do the x determinant. So in the x column, I'm going to put negative 1 and 1. The y column stays 7, 6. So negative 6 minus 7, which is negative 13. Do the same thing for your y. So my x stays 5, 6. And now my y goes to negative 1, 1. Which gets me 5 minus a negative 6, which is 11. Yep, so my x is d of x over d, which is negative 13 divided by negative 12, which is just 13/12. My y is dy over d, which is 11 over negative 12, so a negative 11/12. So 13/12 and negative 11/12. So the nice thing about Cramer's rule is when you end up with fraction answers, you only have to deal with the fractions until the very end. Unlike if you were doing it with inverses, then you'd be dealing with those fractions all within your row operations, right? Well, no, you're going to have to do all the methods. That's the purpose of this chapter. Can you do all the methods? Okay. All right, so now I'm going to pop the 3 by 3 up here. Please don't write everything down, because it's just kind of the same concept. The only thing that I would write down is I would add in this. We already have the x and the y, so now we're adding a z. But the same rule applies. So your d just stays the coefficient matrix. Your x, what happened? We took our solutions and input them into the x column, right? So my a got replaced by the d's, but the b and the c's stayed. Does everybody see that? For my y's, we took our solutions and input it in place of the b's, which is where your y's are. And the a and the c stayed. And then now for the z, we're inputting our solutions into the third column. Do you guys see that? Again, I wouldn't take the time to write all that down. Just keep that thought process in your head. You put the solutions in place of the column that you're solving for, or doing your determinant in respect of. All right, so let's do a 3 by 3.
Do I need to write that? No.
No, I wouldn't write all that down. All right, so we've got the system x plus y minus z equals negative 2. 2x minus y plus z equals negative 5. X minus 2y plus 3z equals 4. And this is just a matter of keeping it organized. All right, so let's do the coefficient first. So d is equal to 1, 1, negative 1, 2, negative 1, 1, 1, negative 2, 3. And what do we do for the 3 by 3s? Rewrite the first two columns directly after. All right, where do I start? Top left, work your way down. So we got to take care of that first row. So 1 times negative 1 times 3 is going to get me to negative 3. 1 times 1 times 1 is 1. That gets us positive 4. So when I add all those together, we get 2. Yeah? You guys agree with that? So we're going to do 2 minus. Now let's go the other way. So work on the bottom row. 1 times -1 times -1 is +1. And we get a -2. It looks like a 6. So if I add all those together, we get 5. So 2 minus 5 gives me a result of -3 for your coefficient determinant. You okay with that? Alright, so now let's do our d of x. So now I'm going to take my solutions matrix, or my solution elements, and put them in place of the first column. So I have a -2, a -5, and a 4. My b's stay 1, -1, -2. My c's stay -1, 1, and 3. Repeat the first 2 columns. Alright, start on that top left. Gotta take care of the first row. Top row, so it looks like we're going to get a +6, +4, and a -10, which gets us 0. Are you okay? Am I going too fast? Now work the bottom row, just multiplying. So 4, get another 4, and looks like a -15. So 8 minus 15 is -7. So I get a +7 for my d of x. Alright, now let's do d of y. Do it up here. D of y is going to be, so my x stays 1, 2, 1. And then I'm going to input into my second column -2, -5, 4, -1, 1, 3. Bring back the first 2. Do your loops. You who are less chatty, we want to be falling behind the 8 ball. So we got a -15 on my first product. Looks like we got a -2 there. A -6. So -15 plus -2 is -17, and another -6 is -23. I don't know, watch my mental math. I'm trying to do this all in my head. Here we got a 5 plus a 4 plus a -12. So 9 minus 12 is -3. So -23 minus a -3 would be -20. My dy. And now we got to do the last one, which is our z. So 1, 2, 1. My y stays, so the second column stays the same with my coefficient. So 1, -1, -2. And now my third column is going to be my solutions, which are -2, -5, and 4. Are you guys following this? Bring back the first 2 rows. doing the same process over and over again here. First diagonal gets us a -4. And we get a -5. And a +8. So that's -1. Work off the bottom. 2 plus 10. 4 times 2, so 8. So that gets me 20. So -1 minus 20, which is -21, would be my determinant in respect to z. Okay, whew, all that. Now we just have to do some division. Tell me what my x is going to be. What over what? 7 over -3. What's my y going to be?
It's gonna be like
20 over -3, so +20 thirds. What's my z going to be? -21 over -3, which is 7. So I got the tripled order of -7 thirds, 20 thirds, and 7. 3 by 3. Is it hard? No. Time consuming? Yes. With the 3 by 3s. But 3 by 3s are always time consuming, right? So there's definitely less chance of making error here. And it's a lot easier to check your errors if you feel like you're wrong than it is with row operations. That's why Cramer's rule is nice. Okay? All right. So I'm going to